Hello friends, welcome to session 12 on projection of plane surfaces. Here we'll be doing alpha and beta constructions, that is management of true inclinations with respect to VP and HP. They are alpha and beta constructions. The problem what we face here is with respect to, in particularly in laminae, with respect to a median or diagonal or diameter in case of circular lamina, we will have been given two true inclinations, one with respect to HP and VP. Okay, when two true inclinations have been given with respect to a median or diagonal or this diameter in any of these laminae, we'll have problem in the third stage. How to overcome is the problem here. Okay, this alpha and beta construction is a crucial thing what you have to know in managing so many of the problems. Whether beta construction is necessary or not, you have to identify at a very early stage. See here, the same thing will continue in solids also, where with respect to axis or with respect to any slant edge or whatever it is, two true inclinations would have been given, one with respect to HP, one with respect to VP. Under such circumstances, you have to manage it and you have to do this construction because the construction carries the maximum weightage. Whether you understood the subject or not, it will be known from this. Okay. Now you see here. Now a simple problem will take up. A triangular lamina size 25 has an edge on HP. Okay, edge on HP means you know very well. You have to start from the top view only. With a median containing the edge is inclined at 45 degrees to HP and 40 degrees to VP. Now you understand here. A triangular lamina has an edge on HP. That means you have to start from the top view. And there is a median connected with the triangular lamina. For that, with reference to this median, two true inclinations have been given, 45 degrees to HP and 40 degrees to VP. Under these circumstances, this construction is absolutely necessary, otherwise it will go wrong. Okay, draw projections and show clearly the construction involved and all that. Okay, now we draw triangular lamina. Okay, you draw triangular lamina ABC as usual, and this is 25. This is 25 plus 30, plus 30. This is 25 minus 30. In that way, you are able to complete triangular lamina of 25 sides. CX is the median. Please understand, CX is the median. And this is XY line, VP, HP. When you're looking from here, B dash, A dash, and X dash all in a bracket. Only B can be seen, X dash and A dash. But CX is an imaginary line. It's a median of this. Okay, median of this triangular lamina. It's not an edge. Okay, then this is C dash. Okay, this is the front view. Now, if you lift this up, it will be resting on edge on HP. If you lift this up, it will be resting on corner on HP. Okay, now when you lift this up, anyway, when you lift this up, no, when C is lifted up, anyway CX will be parallel to VP only. That is why this front view and this front view will remain same. This I have told you so many number of times. Now, since this C is lifted up, okay, C is lifted up, this CX is still parallel to VP. As a result, this median is in true length here. Please follow. This median is in true length here. The median is inclined at 45 degrees to HP. What they are given, you already met that. You 45 degrees to HP, get the top view. Okay, you see here. Now, 45 degrees to HP and 40 degrees to VP. Okay, now median containing this edge is inclined at 45 degrees to HP. You have done, this is true length. You have managed this. This is median containing the edge is inclined at 45 degrees to HP, 40 degrees to VP means, please understand, it is the true length of the median should be inclined at 45 degrees to HP and also 40 degrees to VP. Both should be true length only. See here, now 45 degrees to HP. Don't you think it is true length? Up till here it is correct only. Okay, but the median should be inclined at 40 degrees to VP. But the problem lies here. This median is not in true length here. Can you understand? This is not in true length. Now we have to undergo construction because this here it was 45 degrees to HP. This was in true length. This median, since it is parallel to VP, this is in true length. This true length only we have inclined at 45 degrees to HP. That means median inclined at 45 degrees to HP holds good. Up till here it is correct. But the median now is CX, which is not in true length because it is inclined at 45 degrees to HP. It is not in true length. But what they want is, what the problem says is, the true length of the median should be inclined at 40 degrees to AP. For that, you see here, you draw one construction. Draw one line at 40 degrees. Because the true length of the median should be inclined at 40 degrees. What is the true length of the median? You take this length, this CX, no? That is the true length of the median. You cut an arc here, okay? This is the true length of, okay, XE1, what you cut, that is this length. This length you take, this is the true length of the median. This length you take, okay, and cut here, that is XE1. Then XC you cut, XC1 is actually 22. XC is 15. That is, you see here, this is XC, this is 25. This is second stage top view length, no apparent length, that is 22. You measure this length, measure this length also. True length is 25, this is 22, whatever is that. You see here, XC1, you cut 25, whatever is the true length. Okay, that is 22. Okay, XC1 is 22, length is 22. XC is 15. That is second stage top view length. Okay, XC is 15. This you cut. Please remember, 22 and 15 means one cutting is of true length. That is this 22. This you measure, this 22. Another length, another cutting is this. One true length, one apparent length. Okay, one apparent length of the same median you should cut. Okay, now you see here, one is 22, you cut 40 degree. Then you cut 15 also of that second stage top view. Then you get this beta. This is the beta. Okay, now what you do is you incline this at beta. You incline XC at beta, that is top view of the median. XC is inclined at beta, so that the true length of that will be automatically at 40 degrees to AP. Okay, now you see here, I have moved and copy, I have pasted here and rotated in such a way that XC is, that C merges with this C, and XC is inclined at beta. Okay, XC is inclined at beta. This construction you should know. Okay, one construction XC1 is equal to 22, XC1 22, that is this. Then XC is 15, that is this. Okay, once you get this, this will be beta. Okay, I'll repeat. XC, first you draw a line at 40 and measure this true length. This is 22. 22 you cut here, draw one locus line here, draw one locus line here. Then take this second stage top view length, cut it here, you will get XC, no, this C point. Then this move, copy, paste here at X with reference to this, you paste here, rotate so that this C merges with this C. In that way, XC is inclined at beta. Now once you have done this, when you are looking from front view, how it appears has to be drawn. Okay, this you, as you know already, this you know already, this lamina is resting on edge AB on HP, with surface or median inclined at 45 degrees to HP. Okay, and the same median is inclined at 40 degrees to VP also. Okay, in this complex position, when you are looking from the front, how it appears has to be drawn. You just see here, take the projectors up. On this you should see, on this you should see AB. In that way, you complete this. Okay, now if you have done this correctly, okay, if you have done this correctly, only one checking is you can do it yourself. You have done the construction and all that. Okay, this procedure is proper, and once you know the lines, no, you will know this procedure. This X, okay, this will be X dash here. Can you imagine this? X is, the problem is over here. The problem is over. I'm telling you one proof whether what you've done is correct or not. Okay, now XC is this top view. If you take here, you will get X dash here. X dash C dash is the front view. Can you understand? When you make the front view parallel to XY line, when the front view is made parallel to XY line and hit against the locus, it will meet this. It will automatically be the true length. In that way, the procedure what you have undergone is correct. Okay. Did you follow? I tell you the verification is what you've done is correct or not. In case you take this x, it will meet somewhere here. Then x dash c dash is the front view. XC is the top view. Rotation of front view parallel to XY line and hitting against the locus will give the true length. Okay. That is what we do it in lines. Okay. This procedure will be knowing in lines and the same thing. In that way you can prove it. Anyway, this is the thing. The problem gets over. That is a triangular lamina of size 25 has an edge on HP with a median containing the edge at 45 degrees to HP, median content, and 40 degrees to VP. And it is 40 degrees to VP means you can't draw 40 degrees to VP because this is not in true length. That is why I take first true length and cut 22 here, get the locus, get the second stage top view length, cut it here, okay, get beta, then you XC, you incline it at beta so that the true length of this will be inclined at 40 degrees to VP, and this is the construction which has to be shown, and this is proper. This is problem 2 under VTO, okay. Now you see here, a square lamina of size 40 has a corner on HP. Corner on HP means again top view starting, with a diagonal containing this corner is inclined at 30 degrees to HP and 45 degrees to VP. Again you see here, top view starting, corner on HP, with a diagonal containing this corner, with reference to one reference line, that is diagonal, two true inclinations have been given, one with respect to HP and one with respect to VP. Compulsorily you need beta construction even here. See here. Now a square lamina I draw. These things you know. A, B, C, D you draw. Then A dash, B nearer, D away, B dash, D dash. This is C dash. Okay. Now you see here. This is the diagonal. This is AC now. This is in true length because AC is parallel to VP. Hence you see the true length in the front view. Then once you tilt it, once you lift this over C dash, A dash, C dash, okay, AC, even if you tilt it now for 30 degree, this AC is still parallel to VP. As a result, this front view and this front view will remain same. Now it is 30 degree. That means diagonal AC is inclined at 30 degrees to HP. Up till here it is correct because the true length only I have inclined at 30 degrees to HP. I'll get the front view here. I'll get the top view here. For this, A, B, C, D. Now, the diagonal containing the corner is AC, no? Here it is 30 degrees to HP is okay. But what about here? AC, since it is 30 degrees to HP, this is apparent length. Did you follow? Now you have to be careful. This is apparent length, which has to be inclined at 45 degrees to VP. Okay. This I can't directly incline it at 45. If I incline it at 45, it will be the top view of the diagonal which will be inclined at 45. Now we have to undergo the construction. One true length cutting, one apparent length cutting. You see here, the true length you take. This AC, this is ACX, let us say. This length is 57. You cut 57 on this 45. Get the locus line. Okay. Then once you get the locus line, take this AC length, top view length, cut it here. Cut it here. Now this will give rise to beta now. Now this AC should be inclined at beta to XY line. Now what do you do? Move, copy, paste with respect to A, okay, and rotate such that this C coincides with this C. Now AC is inclined at beta to XY line. In that way, you have undergone the beta construction. Okay, this AC is inclined at beta so that the true length of AC is inclined at 45 degrees to VP, which is the problem. Okay, take the front view. When you are looking from here, take the front view, you draw this. In that way, the problem gets completed in all respect. Okay, I am telling you again, you please follow. It's a typical problem what you get in the examinations where you need to know the construction. Here there is a square lamina, ABCD. You draw the front view, corner on HP, correct? No? Corner on HP means corner position you should take because you know for square lamina, corner position is different, edge position is different. Corner on HP. The diagonal contain the corner. This is anyway, this is A dash C dash is in true length. 30 degrees to HP you do, you get the top view. Okay. But here AC is not in true length. But the true length of this should be inclined at 45 degrees to VP. That is why we have to undergo this construction. Okay. The true length should be inclined at 45 degrees to VP they are given. That is why true length you take it, that is 45 degree line. True length, this length you measure, cut it here, get the locus, and then take AC, cut it here, rotate in such a way that AC is inclined at beta to XY line. Get the front view. In that way, you complete. Thank you very much for watching. We'll continue.